In the screencast, we're going to talk about the importance of sex, fitness, and genes. And we'll first start off by talking about why asexual is important before we talk about why sex is important. If you think back, you'll remember we did some microscope work where we were looking at asexual reproduction. And then you did some research for homework on plants that are undergoing asexual reproduction as well. So clearly there are a lot of organisms that are doing it, so there must be some good things about using asexual reproduction. So what are they? First, we create genetic clones. So if an organism is in a static environment, meaning one that's not going to change much, then why would you want to change yourself? Because if it's working for you, then it's going to work for your children. Second, asexual reproduction requires very low energy, right? The amount of energy that it costs is not very much. The organism doesn't have to find a mate, it doesn't have to create an egg, the organism doesn't have to incubate an egg, you don't have to have a gestation period. All of those things are costly. Third, when using asexual reproduction, there's no need to find a mate. Finding a mate isn't going to be a big problem if you have a high population density, but if you are spread out in an area that's miles away from other organisms, it definitely could be an issue for sexual reproduction. So those are the three main reasons why asexual reproduction is a good thing. So given that, why would you want to have sexual reproduction? The number one thing is that it leads to variability in the successive generations. So if the organism is in an environment that's changing, it can actually change itself. And this would be beneficial if there's this change in the environment. But it could also be hurtful, right? There are some subtle changes that you might want to make that could be beneficial, though. Second, with sexual reproduction, we get a faster rate of evolution per generation. So this doesn't mean that the organism is going to evolve faster, right? The important distinction is that it's per generation it is faster. If you think about humans, right, our generations are about 25 years. So in 25 years, you can go through millions of generations of bacteria, whereas as humans, we're only going through one generation. So overall, bacteria, they can evolve faster through mutations. That's not happening through sexual reproduction, though. Whereas humans, they can change and they can adapt through the combination of both mutations and recombination that we have associated with sexual reproduction. There are also going to be costs associated with sex, and they're basically just going to be the opposite of the benefits associated with the asexual reproduction that we discussed here. So first off, they need to find a mate. That costs money. Sex is going to be energetically very costly. And then lastly, if you don't want to change, then sexual reproduction is not going to be a great thing. So let's now make a connection between sexual reproduction and this concept that I mentioned here of fitness. The idea of fitness is an important one, and when we're talking about fitness, it's not the same thing that we mean when we're talking about physical fitness, although it is somewhat connected there. So fitness involves one major thing, which is being able to survive long enough so that you pass your genes on to the next generation. So let me write that down. The organism wants to survive in order to pass its genes on to the next generation. So this doesn't mean that the organism has to live long. It just means that it has to be efficient in passing its genes on to the next generation, and that its offspring is going to be efficient in passing its genes on to the following generation. If an organism is just living for a long time and it's sterile, it won't be able to do anything because it can't pass its genes on, so it has a low level of fitness. But if an organism, even if it's only has a short life, but it's able to reproduce a whole lot, then it would have a high degree of fitness. And sexual reproduction allows you to accumulate genes that increase your fitness. And when that happens over a period of time where you are accumulating good genes, then the population tends to shift. And Ultimately, this is a process that we know as evolution. Now, the last topic that I want to mention is a concept of survival of genes. So let's go to the next slide here. And this is something that's definitely interesting to think about. It was a concept that came up with by a man named Richard Dawkins. And he proposed that organisms, they're simply just going to be survival machines for their genes. So let me draw an example here for you. Here we have an organism that's kind of a combination between a turtle and a giraffe. And inside of it, it has those pink genes, DNA. And so this combination organism, this giraffe turtle here, he's really good at surviving and passing his genes on to the next generation. All it needs to do is reproduce. So if it needs to do that through asexual reproduction, then it will do that. And the genes are going to prefer this because they're just going to get exact copies of themselves. So keep in mind that it's kind of evolutionarily ingrained in an organism whether or not it will do asexual or sexual reproduction. So it's not like it usually has a choice here. But let's say that there also was the opportunity for this organism to undergo sexual reproduction, right? So if it makes more sense for it to use this, let's say it's something that it's evolved for it to do and its environment is fickle or it's changing, then using sexual reproduction will pass on a greater percentage of its genes to the next generation, right? So if this turtle could have a choice, and you're thinking of it kind of like game theory, and it does asexual reproduction, then typically, 100% of its genes will be passed on because it's just an exact copy of its DNA. But let's say in the next environment, all of those turtle giraffes, they become extinct. And now 100% of these original genes are not going to be able to be passed on. So 0% again if the environment changes there. So therefore 100% of those genes will not be passed on. But if it underwent sexual reproduction, the sexual form of reproduction, let's say maybe only 50% of its genes are going to be passed on, right? Because you're going to have some that's from the mom and some genetic material from the dad. Let's say in this example, it's getting half from this dad. But because the offspring have adapted to this new environment, in the long run, maybe not 100%, but a lot more than 0 of the organisms in the next generation with the changed environment will live. So, if you want, hypothetically, you can say 100% of them survive. Probably that will not happen, but because the offspring have adapted to it here in this situation, then, a huge chunk of them will survive, and then they'll pass their genes on. So it's a little bit of a game that's being played out by organisms over millions of years, and we see this with evolution. So just to recap, today we talked about the survival of genes, then talked about the concept of fitness, how that plays a role in sexual reproduction, talked about how sexual reproduction is a valuable thing versus the advantages that we have in asexual reproduction. And that's all I have for you.